All right, let's do this example here. So I've got, in this case here, we've got two equations with three unknowns. Okay, so let's go through our process. And so, what are we going to do? Well, we've already got the x here, there's no other x's, so let's get rid of the y's. And in this case here, how can we do that? Well, oh, we've already got it. Oh, hold on a second. We've already got an echelon form, right? So we're done, right? Well, what does that mean? So we have this system of equations, right? We get down to this, and we really can't reduce it any further, right? We got an echelon form, we're done, right? There's all the variables, the leading variables are to the right of the variable above it, right? So what does this mean? We've got this system of equations, but we don't have a 0 equals 0, but guess what? This is where we can solve this one here, right? For example, let's look at this. Y, what does this mean? Y equals negative z. Y equals negative z. So how do we solve? So there's an infinite number of solutions, but how do we say this? Okay, so this solution is an infinite number of solutions. So what happens here? So y equals negative z, right? If I put a negative z here, I get 0. So, but what happens here? So if y is negative z, what happens here? Well, these go away, x equals 0. So guess what my solution set is going to be? It's going to be 0, and it's going to be what? Negative z and z. So that means z is free to be whatever you want it. It's a free variable. Okay, it's free to be whatever you want. But once you say what z is, then as long as this is the opposite of that, negative z, and the first variable x is 0, then it's a solution. So here's an example of a system of equations that has an infinite number of solutions, but you don't get 0 equals 0. Okay? Have a good day.